This video in the Pure Maths 1 course covers changing the base of logarithms and solving exponential and logarithmic equations. Now, if y equals log of x to base a, we know that we can write this as x equals a, the base to the power of y. Now, supposing we take logarithms of both sides of this equation to another base b. Log of x to base b equals log of a to the y to base b. And then by the third rule of logarithms, that when we have a logarithm of a power, we can write the value of the index of y as a multiplier of the logarithm, like that. So log x to base b is y times log of a to base b. So dividing through by log of a to base b, we get y equals log of x to base b over log of a to base b. But of course y is just log of x to base a. So we have the result log of x to base a equals log of x to base b over log of a to base b. Therefore we have written the logarithm of x to base of a in terms of the logarithm of x to another base b. So for instance, log of 5 to base 3, if we wanted to write that in terms of log 10, log to base 10, we can just introduce the base 10 by writing log of 5 to base 10 divided by log of 3 to base 10. I think we can see in this formula here for changing the base of a logarithm, the x and the a on the left hand side, x to base a, have x in the numerator, log b to base x to base b, and a in the denominator, log a to base b. So the 5 and the 3 here are 5 in the numerator and 3 in the denominator. This may be useful in calculating the numerical value of a logarithm. The logarithm of 5 to base 3. For instance, as many calculators do not have the ability to calculate logarithm to base 3, they only have logarithm to base 10. So on your calculator you can look up the logarithm of 5 to base 10 and we'll get 0.69897 to 5 decimal places, and the logarithm of 3 to base 10 we'll get 0.47712 to 5 decimal places, and doing that division we find that comes to 1.4650 to 4 decimal places. Though some calculators do have a button for log of a to base b where a and b can be any value. Now there is a special case here. Supposing x equals b, we'd have log of a b to base a equals log of b to base b over log of a to base b. And log of b to base b, of course, is 1. And so we have the result log of b to base a is 1 over log of a to base b, and therefore in this way we can interchange the two values, the base and the value that we're taking the log of. For instance, log of 5 to base 3 is the same as 1 over log of 3 to base 5. Now we come to solving exponential equations. An exponential equation is an equation where the unknown x is in the exponent or the power or the index. So for instance, a very simple exponential equation is 2 to the power of x equals 3. To solve it, we want to find the value of x. Well, very simple way of doing this, we could take logarithms of both sides to a base that we can find, like base 10. And then using the index, the logarithm law, we can write x log 2 to base 10 is equal to log 3 to base 10, and dividing by log 2, x equals log of 3 to base 10 divided by log of 2 to base 10. And using the calculator, we can calculate that to be 1.585 to 3 decimal places. Alternatively, I could have written 2 to the power of x equals 3 directly in the logarithmic form, x equals log 3 to base 2, and either look that up directly on the calculator or using the change of base rule, we can write that as log of 3 to base 10 over log of 2 to base 10, which equals 1.585 as before. A slightly more complicated example, 3 to the power of x plus 1 equals 2 to the power of x minus 1. We do the same, use the same technique, take logarithms of both sides to base 10. So log 3 to the x plus 1 to base 10 equals log 2 to the x minus 1 to base 10. And using the laws of logarithms again with the power law, we have x plus 1 log of 3 to base 10 equals x minus 1 log of 2 to base 10. Now, log 3 to base 10 and log 2 to base 10 are just numbers. This is very similar in a sense to the equation 3 times x plus 1 equals 2 times x minus 1. I've replaced log 3 and log 2 with 3 and 2 because log 3 and log 2 are numbers, and if we wanted to solve this equation, we would just expand the brackets. 3x plus 3 equals 2x minus 2. Collect up the x terms. 3x minus 2x is x, and subtract 3 from both sides, we'll get x equals minus 5. Well, we do the logarithm equation in the same way. We expand the bracket. Log to base 3 times x, which we might write as x log 3, but it is just a number times x, plus log of 3 times 1 base 10 equals x log 2 minus log 2. And then, as before, we'll collect up the x's on one side and the numbers on the other side. So I'm going to subtract x log 2 from both sides. We'll have x log 3 minus x log 2 and then subtracting log 3 from both sides, we'll have minus log 2 minus log 3. Factorising the left hand side, x times log 3 minus log 2 equals, and factorising the right hand side, minus log 2 plus log 3 to base 10. Again, log 3, log 2 are just numbers, so I can divide by log 3 minus log 2, and we get x equals minus log 2 plus log 3 over log 3 minus log 2. Now this is x in its exact form. You can't write x exactly in any other way. Looks complicated, but the log 2 and log 3 are irrational numbers, so if a question in the exam asks for an answer in exact form, you would leave it like this. If you need to write it to decimal places, a number of decimal places, then you use a calculator. And it equals minus 4.419 to 3 decimal places. Our third example is equations of this form, where we have 2 to the power of 2x and also a 2 to the power of x term in the equation. Now, to solve equations like this, we need to recognize or use one of the indices rules, and the one that says a to the 2x, or a to the nx, is equal to a x to the n. So in this case, 2 to the power of 2x can be written as 2 to the x squared. So our equation becomes 2 to the x squared plus 4 2 to the x minus 5 equals 0. And you might recognize this sort of equation as a quadratic. We have an unknown squared plus an unknown term and then a number term, and equals 0. We can make a substitution. We'll let y equal 2 to the x, and then the equation will become y squared plus 4y minus 5 equals 0. Now, you might know how to solve a quadratic equation. If you're not sure, then go to the quadratics topic in this course and revise how to solve quadratic equations. This equation is solved by factorising. We can write it as y to make the y squared, 5 and 1 multiply to give 5. We need plus 5 and minus 1 to give the plus 4y term in the middle. So solving that equation, we have y equals minus 5 or y equals 1. But y, of course, is 2 to the x. So we have 2 to the power of x is minus 5, or 2 to the power of x equals 1. Now, an exponential function is always positive. There are no values of x for which 2 to the x equals minus 5, so we have no solutions for that one. And if 2 to the x equals 1, we have x equals 0. So just one solution to this equation. Our fourth example is a logarithm equation, a logarithmic equation. Log of x to the base 3 plus 8 log of 3 to base x equals 6. Now to solve this equation, as we notice that the unknown x is in one term the subject of the logarithm, log x to base 3, and in the other term it is the base of the logarithm, log of 3 to base x. Now when you see this, you should remember the changing of the base rule. Log of a to base b is equal to log of b to base a. The special case in which you can swap over the subject a and the base b, and therefore you can remove the unknown x from the base, because we can say that log of 3 to base x is equal to log of x to base 3. So the equation becomes log of x to base 3 plus 8 log let's just repeat that, because that was incorrect. Log of 3 to base x is of course 1 over log of x to base 3, and the rule, of course, log of a to base b was 1 over log of b to base a. So log of 3 to base x is 1 over log of x to base 3. That's what we use to substitute into the equation. So the first term is log of x to base 3, and that equals to 8 over log of x to base 3, plus log 8 log x to base 3 equals 6. Well, again, let's make a substitution. The substitution simplifies the equation. We'll let y equal log of x to the base 3 this time, and the equation therefore becomes y plus 8 over y equals 6. And to solve this equation, we'll multiply through by y squared plus 8 is 6y, and then subtracting 6y from both sides, we get the quadratic y squared minus 6y plus 8 equals 0, which factorizes, of course, y and y, 4 and 2, minus and minus, to give us 6 equals 0. And so y equals 4 or y equals 2. But y is log of x to base 3. So the first solution, log x to base 3 equals 4. Well, that gives us x is 3 to the power of 4, which is 81. And the second solution, we have log of x to base 3 is 2, or x equals 3 squared, which is 9, and so the solutions are x equals 9 or 81. Now return to Study Smart to practice yourself.